and welcome to my channel. We are going to study about the double tune filters. What is double tune filters? Double tune filters are the filters which is a combination of two different single tune filters which aim to eliminate the two different harmonic frequencies. As we already know that single tune filter will eliminate single frequency, harmonic frequency. So the double tune filter must eliminate two different harmonic frequencies. So we can also use two single tune filters, two different single tuned filters. We can use it also in power lines. And the double tune filter is a combination of R, L, and C in series and parallel combinations, so that uh, it will require a less amount of uh, inductor and capacitors. We can say that there's a combination, a single type of combination, single overall combination, so that it will be used to consume less power and its equivalent values. Uh, it will be explained in diagrammatically as follows. So for let first I will write that one single tune filter tuned filter uh, eliminates one particular type of harmonic frequencies. Harmonic frequency, two single tuned filters can eliminate two different types of harmonic frequencies. So one double tune filter can eliminate two different types of harmonic frequencies, right? So one double tune filter is equivalent to two single tuned filters, correct? So diagrammatically I can write that this is a power line, this is R, L, and C. This is a single tune filter connected to a common point of coupling. This is R, L, and C. This is R, A, L, A, C, A. This is R, B, B, and C, B. And what is this? This is a two singleton filters. And this is the singleton filter, whereas let's make doubleton filters. R, L, and C. This is similar to singleton filter. This is a series combination, and the parallel combination of R and C, R and L. This is a doubleton filter, right? So let's write this as an R1. This is L1. This is C1. This is R2, C2, R3, and L3. Okay, it starts. This starts with the following curves. Let's say I can also put two singleton filters as a parallel combinations of R and C, R and L like that. Sorry, this must be parallel combination. This one and this one also. This can also be true. Two singleton filters series and two singleton filters parallel. This is series one. This is parallel one. Okay, both are same. And now, what will be the characteristics of singleton filter and doubleton filters? Let's examine it as follows. Okay, uh, let's write the characteristics of this one, and the another doubleton filters. Both the curves have the x-axis of omega. This is ZA or ZB, ZA or ZB. This is ZAB. We can say ZAB like this. This is a CA, CALA, CBLB. This is also ZA or ZB. As we know that during resonance, there is a resonant frequency omega r, and the curve goes like that. This is the curve. Okay, B curves. This is capacitive. This is inductive. This is the reason where omega is greater than omega r. This is omega is less than omega r. This is the characteristics, and this is when Z is equal to Ra, or we can write Za or Z equal to R. Okay. For this, under the resonance condition, omega r, the condition is like this, hyperbolic. I will not explain these curves in this topic. You can study it, capacity part. This is inductive. And for this, for Doubleton filters, it is the combination of both this as well as this. Sorry, I think like that. This and this and this, both one. This is capacitive. This is inductive. This is uh, yes, capacitive, and this is inductive. This is omega. This is omega r series. This is omega r parallel. This is double tuned. That is series plus parallel. Series 1 is connected in series with the parallel circuit. Here this is the series 1 series, and this is parallel 1. This is series 1, this is parallel 1. Right? Let's move forward. What are the advantages of double tune filters. What are its advantages? The first advantage is that one inductor, one inductor L1 instead of two LA and LB. We can place one inductor L1 instead of LA and LB. And another one is that the insulation level, basic insulation level BIL on L2 is reduced. Here we can see that this is L1, this is L2. Sorry, I have written L3. We can say L3 or L2 as well. L2 and this is R3, R1, 2, 3, L1, C1, L2 and C2, right? The insulation level, for example, if it is a 66 kV line, or say it is an 11 kV line, the potential across this circuit is 11 kV. Whereas if this is an 11 kV line, the potential is divided. This may have potential of 5.5 kV. So the insulation level is reduced because insulation level depends upon the voltage levels. This is an example. Uh, Another advantage is that we can use double tune filter DTF in high voltage systems. We can use this in high voltage systems, and the DTF occupies less space. So what are the key points? That we can one inductor L1 instead of two LA and LB can be used. Basic insulation level is reduced. We can use this DTF in high voltage systems, and it occupies less space. And a combined tuning is possible. And advantage is that combined tuning is possible. What is combined tuning? So after tuning of DTF, we can use a single tuning mechanism. We can tune through R1, and we can ignore the terms R2 and R3. We can tune R1. We can also use R2 to tune the overall circuit as well. So the combined tuning is also possible here. And combined tuning is also possible. So let's go to another question related to this. So if the question is this, derive the expression between double tune filters, double tune filter L1 C1 L2 C2. So the R is resistance is ignored in terms of parameter, in terms of parameters of uh, two parallel single tune filters. Single tune filters LA, CA, LB and CB. So what is the question here? we have two singleton filters. The R is eliminated, so we say that this is the combination of L and C, C and L, C and L. This is singleton filter, which is equivalent to uh, doubleton filters like this, uh, L and C, series and parallel. Okay, singleton filters this in series. Two parallel singleton filters, two parallel singleton filters, LCA, LBCB in series. Okay, so this is an this is CA, this is LA, this is CB, and this is LB. This is L1, C1, this is L2, and this is C2. Let's start the solution. Solution starts from the first part. For single tuned circuit, also single tuned circuit, ZAB is, what will be it? This is ZA, this is ZB, this we say Z1, this we say Z2. So what is ZA? ZA is LA and CA is in series. So ZA parallel to ZB. So what will be ZA? ZA is, so we write this CA as XLA. What will be it? It will be 2 pi FLA, right? So what will be for this? XCA 1 by 2 pi FCA. So what will be the complex quantity? J here and J below. Okay. So what will be the ZA? ZA is J 2 pi F. In case we say that the 2 pi F is common in every case, so we can write omega is equal to 2 pi F for both the frequency. The frequency is same for the natural frequency of the line. The line is common with frequency F. So 2 pi F is omega L J omega LA plus 1 by J omega CA, correct? Parallel to J omega LB plus 1 by J omega CB. This is the another one. So after writing this will become 1 minus omega square LACA divided by J omega CA. This is the expression parallel to 1 minus uh, omega square LBCB divided by J omega CB. Next, you know that A parallel to B will give AB divided by A plus B. You can write this. What will be the AB? 1 minus omega square LACA 1 minus omega square LBCB divided by J omega will give minus omega square CACB. This is the numerator part, right? A times B. And what is A plus B? 1 minus omega square LACA J omega CA plus 1 minus omega square LBCB divided by J omega CB. Correct? Now simplify this. 1 minus omega square LACA 1 minus omega square LBCB from the numerator part divided by And you can simplify these terms also. 1 minus omega square LACA times j omega is taken common. Here we see that the j omega part is common here. Okay, so I will take 1 by j omega right here. Okay, and I will multiply with only CB, okay, plus 1 minus omega square LBCB multiplied to CA and divided by CACB. Sorry, CACB will go to the numerator, CACB will go to the numerator, so it is CACB divided by what will be the denominator of the numerator, omega square CACB. So CACB goes out in this way. We say that this omega and this omega will also cancels out. So what will be the value? Minus omega by j. So j by minus omega, right? J by minus omega. So what will be the j by minus omega? 1 by j omega with j by, so minus is j square omega, so it is 1 by j omega, correct? So I can write this expression as 1 minus mm, omega square L A C A 1 minus omega square L B C B divided by j omega here j omega mm, I multiply this CB minus omega square LACA CB plus CA minus omega square LB CA, correct? Let's move forward. 1 minus omega square LACA 1 minus omega square LBCB divided by j omega. Arrange the terms. It will be CA plus CB minus, take omega square CA CB as a common. It will be LA plus LB, right? Okay. Next, we write this and multiply the both terms on the numerator. We can multiply on the both terms of the numerator, or we can leave it as it is. But we don't want to leave it as it is because we need to calculate the power terms, because some terms may be omega to the power 4 and one term may be omega square and omega to the power 4, and we need to equivalent to the powers. Now multiply the numerator terms as follows. We can write this 1 minus omega square LBCB uh, minus omega square LACA plus omega 4 LACA LBCB, correct? Divided by j omega, same terms, omega square CACB LA plus LB. You will understand that later on why we are doing this. 1 minus omega square LACA plus LBCB plus omega 4 La Ca Lb Cb divided by j omega Ca plus Cb minus omega square Ca Cb La plus Lb. The expression is a bit long, so we divide the parameters. We define the parameters as follows. Let parameter P1 is the parameter of omega square LACA plus LBCB, right? P2 as LACA LBCB product. P3 as CA plus CB and P4. These are the parameters CA, CB, LA plus LB. So the expression becomes, what will be the expression? This is the expression of the equivalent impedance of ZAB for two singleton filters, correct? ZAB. So this is a very complex quantity. 1 minus the omega terms is kept same because we have to eliminate the omega terms with the equivalent impedance of the double tune filters in order to calculate L1, L2, L3, L1, L2 and C1, C2 in terms of LA, LB and CACB correspondingly. Okay, ZAB. What will be the value of ZAB then? 1 minus omega square. Put the value of P1 here. P1 plus omega 4 P2 divided by j omega. CACB is P3 minus omega square P4. This is equation 1. So now in step 2, this is the step 1 we calculated that for a single tune circuit we are calculating the equivalent impedance ZAB, and the equivalent impedance of this one we will also calculate in step 2. This is number 1 and this will be number 2. Next one is, so double tune filter equivalent impedance Z12. So this is Z1 plus Z2, correct? These two are in series. So what will be the Z1? J omega L1 plus 1 by J omega C1. Both are in series, L and C, and plus, and another one is in parallel, J omega L2 parallel to 1 by J omega C2, right? Now arrange the terms. This will be 1 minus omega square L1 C1 by J omega C1. You can take the LCM, plus this is J omega L2 times 1 by J omega C2 divided by J omega L2 plus 1 by J omega C2. See, the terms is so much simplified, so double dot filter is easy to control. 1 minus omega square L1 C1 J omega C1, same as it is. J omega cancels out. You cannot cancel j omega so fast, so I will not cancel out this. I will just write j omega L2 by j omega C2 divided by, what will be this? 1 minus omega square L2 C2 divided by j omega C2. So we can cancel out this j omega C2. This will be the nice way. 1 minus omega square L1 C1 and take the LCM. 1 minus omega square L2 C2 plus, so j omega C1 and multiplied to j omega L2 will give us negative sign minus omega square L2 C1, okay, divided by j omega c1 multiplied to 1 minus omega square L2 C2. Thus multiply the above terms 1 minus omega square L2 C2 minus omega square L1 C1 plus omega 4 L1 C1 L2 C2 minus omega square L2 C1 divided by j omega C1 1 minus omega square L2 C2. There is no need to put P1 and P2 terms. You can put Q1, Q2 terms, but it is not necessary here. 1 minus omega square L2 C2, so omega square terms are there are 3 terms, omega square terms. 1 minus omega square L1 C1 L2 C2 plus L2 C1 and plus omega 4 L1 C1 L2 and C2 divided by j omega C1 1 minus omega square L2 C2, right? This is Z12, this is the expression 2. So the condition is that, step 3 we say, the condition is that both singleton filters is equivalent to doubleton filter, so that it can eliminate two frequencies by resonating in its resonant frequency. What did the conditional resonance? Z is equal to R. This is the condition, or XL is equal to XC. The inductive part and the capacity part both must be balanced. So we make that ZAB is equal to Z12. This is the main condition. So we apply this condition from equation 1 and 2. From 1 and 2 equation. So what is the value of ZAB that we have calculated earlier? It is this. This is the value. This is the value we calculated and write it here. This is the value we calculated, and this is equal to this expression, right? This expression you see. So this must be equivalent to this here. Okay, let's write this. This is the toughest part of our equation solving. So the j omega part cancels out here. Nothing cancels out. We have to multiply its cross multiplication. So say let's LHS part. LHS part is the product from here to here. This is the LHS part. Cross multiply terms. So first cross multiply is from LHS and from the RHS. So this is LHS. This is RHS. We will write RHS later on. So first write LHS. First write LHS. Okay. 1 minus omega square P1 plus omega 4 P2 and then times C1 1 minus omega square L2 C2. This is the LHS part, isn't it? And multiply these terms, so you can write C1 separately here. Let me check. Let me check the values. Okay. Yes. C1 times this. Okay. Keep C1 to the left hand side and multiply these two terms. 1 minus omega square L2 C2. The one part is finished, minus omega square P1 minus and minus is plus omega 4 P1 L2 C2, and another one is omega 4 plus omega 4 P2 minus omega 6, 4 plus 2 6, omega 6 P2 L2 C2. This is done, and the C1 remains to the left corner. You can multiply C1 to the all the equations. All the equation we can multiply the C1 to. It doesn't matter. Yes, you can multiply. Okay, let's arrange the terms from omega 6. Let's write omega 6 term. What will be the omega 6 term? Minus P2 L2 C2 C1. Omega 6. This part is finished. Omega 6 part. Another one is omega 4 part plus. Okay. Yes, we can write like this. Omega 4. 6, 4, and 2 parts. Only 3 terms. Only 3 terms. Right? Not 4. Omega 4, omega 6, omega 4, omega 2, and omega 0. Omega 4, we say that these two terms are the omega 4. So add those. P2. First one is P2 plus, sorry, P2 C1. P2 C1 plus P1 L2 C2 C1. This is omega 4. It's finished. Now omega 2 part plus omega square minus L2 C2 C1 minus P1 C1, right? And the last one is C1. This is the single term with omega 0. This is the main LHS part. And for RHS, right, for RHS. Correct? For RHS, uh, for RHS, we have to multiply P3 minus omega square P4, P3 omega square minus P4, and the numerator term is 1 minus, let's copy this term, right? Let's copy this. Let's copy and paste here. You come here, correct? This is the term of RHS. Now equal to, this is a very long term, so we have to solve this very peacefully. P3 minus omega square P3, write this term as it is. C1 plus L2 C2 plus L2 C1 P3 plus omega 4 P3 L1 C1 L2 C2, very peacefully, minus another one is omega square P4 minus, and minus is plus omega 4. This is P4. Same L1 C1 plus L2 C2 plus L2 and C1, and L and C looks the same. Plus plus minus, it is a minus term, negative term omega 6 P4 L1 C1 L2 and C2. Now ends according to the degree of the omega. We have written omega 6. What will be the degree of omega 6? Omega 6 is only one term here, no other terms. So it is minus P4 L1 C1 L2 and C2, right? What will be the degree for omega 4? Omega 4 has two terms. It has P4 L1 C1 plus L2 C2 plus L2 C1, right? Plus P3 L1 C1 L2 C2. Omega 4 terms is also finished. Omega 6 finished. This finished. This finished. Now omega square plus omega square. What will be the terms of omega square? Minus P4 minus P3 L1 C1 plus L2 C2 plus L2 C1. Very peacefully. Okay. Plus P3 is the constant term. So while equating both the LHS and RHS must be equal. LHS is equal to RHS. So equating the corresponding degrees of omega, right? So first of all, we say that we take 0th degree. For 0th degree, uh, let's see from LHS C1. C1 is equal to P3. So what was the value of P3? Let's check this out. The value of P3 was Ca plus Cb, right? P3 was Ca plus Cb. Thus, C1 is equal to Ca plus Cb. Therefore, C1 is equal to, let's write this in red, C1 is equal to Ca plus Cb. This is the final expression of C1. So we have now calculated C1. Okay. Now go to another. Is there any omega 1? No. There is omega 2. Equivalent this. For omega 2, what is the expression of omega 2? This one. Minus L2C2C1 minus P1C1. I think it will be better to copy this. This is right here. This is right here. Okay. This is the LHS. Okay. And what is the RHS? RHS is this. This is RHS. RHS is here. Both are equal. These are equal. And if I eliminate the negative term, then I can write that L2 C2 C1 plus P1 C1. When I multiply minus 1 to the both sides, P4 plus P3, L1 C1 plus L2 C1 plus C2. I can take common factor here. L1 C1 uh, plus L2 C1 plus C2. Let's check this. There is P1, P3, P4. We have calculated the value of C1. We don't know the value of L1, L2, and C2 as well. So it is difficult to solve this equation so fast. So let's take this is an equation number 3, right? We will solve this after when we calculate the other values in next lines. Omega cube does not exist, so omega 4 exists. So this must have something clue, right? Omega 4. So what is the expression for omega 4? Omega 4 also have the same type of expression. So we must first copy this copied here. This is the expression for omega 4 from LHS, and this is the expression for omega 4 from RHS. Correct? This is the expression for RHS. This is an LHS and this is an RHS. This is also equation 4. We cannot solve this so fast because we have only calculated C1. We need to calculate more. Let's say for equation, is there any clue? No clue. So let's check it out from RHS L to C2. Okay, it is correct. Now check omega 6. Is there any clue? Let's check it out. Maybe there is a clue for omega 6. Okay, let's select omega 6. This is omega 6 from LHS, the coefficient of omega 6. This is the coefficient for omega 6, and the coefficient of omega 6 is this, right? The coefficient of omega 6 is this, equivalent this. I think this can be calculated too. So the minus and minus cancels out. L1, sorry, C1 cancels out. L2 cancels out. So P2 and P4 is remaining. So we can calculate C2 or L1 or L2. I don't know, but let's put the value of P2 and P4. Or maybe we can calculate C2 also cancels out, right? So L1 is equal to, what is the value of L1? P2 divided by P4. Remember this, okay? P2 by P4. So what will be the value of P2 and P4? It will be, what is the value of P2 and P4? Let's check this out. P2 and P4. P2 and P4 is LACA LBCB CACB LA plus LB. Getting interesting. LA LB CACB, product of every terms. CACB CA plus CB, product of capacitor terms. So this cancels out. So we get the final solution. Therefore, L1 is equal to LA LB divided by CA. Sorry, this is LA. Okay, let's check this. Okay, this is LA plus LB, right? I was confused. So this is LA LA plus LB. This is the expression. So we got the two terms. One is C1 and another is L1. So we need, in order to calculate L2 and C2, we need to insert L1 and C1 in both equations, omega square equation and omega 4 equation. I mean equation 3 and equation 4. We need to put these values, right? We need to put C1 and L1 in these two equations and solve these equations in order to calculate P2 and in order to calculate C2 and L2. It is a very tough solution. So let's check from from equation 3. Equation 3 is the equation of omega square. So let's copy the equation 3. This is the expression of equation 3, right? Let's copy this and put it here, paste here. This is the equation 3. Okay, let's trust our mind in it. What can we do? So remember P3. Is there any expression that can be converted into L1 and C1? Because P3 is C1. P3 is C1 and P2 by P4 is L1. So first check this out. P2 and P4, if I divide P2 and P4, it is L1. Okay, so there is P3. So I can put P3 as C1. I can put P3 as C1. Okay, C1 value is known. It is CA plus CB. So C1 is known here. C1 is known here. C1 is known. C1 is also known. P1 is also P2 and P3 are always known because they are the expression of A and ABC. So I need to calculate C2, right? L1 is known. Yes, L1 is also known. Okay, I don't know L2. P1 is also known. P4 is also known. And C1 is also known. L2 is unknown. So here is L2 and say that L2 and C2. L2 and C2 is here, sitting here. So I need to reduce this equation. Okay. Okay. I think there is something combinations making inside it. P1 C1, L2 C2 C1, L2 C1 and C1 square, L2 C2 C1 C2, L2 C1 C2. Okay. Let's multiply this. Let's open these terms. Okay. L2 C2 C1 plus P1 C1 is equal to P4 plus P3 is C1, right? C1 it is as it is. So C1 times L1 C1 it is L1 C1 square plus L2 C1 and C1 square plus L2 C1 C2, right? So L2 C1 C2 and L2 C1 C2 cancels out. So we can say that C1 square, we know the value of C1, right? L1 plus L2 is equal to P1 C1 minus P4. P1 C1 minus P4. Okay. P1 is, there is no P2. So let's say this L1 plus L2 is equal to P1 C1 minus P4 divided by C1 square. Okay. I know the value of L1. I can also calculate the value of L2 similarly. So L2 can be, let's say this is equation 3, 4, 5. This is an equation 5. So the L2 value of L2 can be calculated from here. P1 C1 minus P4 divided by C1 square minus L1. I already know the value of L1. L1 value is P2 by P4. Can I write that? P2 by P4. Yes, I can write P2 by P4. Mm, I can write P2 by P4 also. Okay, let's move forward. P1 C1 minus P4. So I am going to expand the value of P1. What is P1? P1 is the value of P1 is LACA LBCB, right? I think I need these values down here. I need to copy this value. I need to copy this value. Let's copy this. Copy and paste here, down here, so that it will be easy to visualize this part. This part is for visualization. Okay, move forward. P1 is uh, LACA plus LBCB, and C1 we have already calculated, CA plus CB. P4 is CACB LA plus LB divided by CA plus CB whole square minus, what is the value of L1 we have calculated is LA LB by LA plus LB. LA LB by LA plus LB, correct? Now you can multiply this and simplify as well. First simplify these terms. LACA LACA square, LACA CB, CACB LB, LACA CB, LACA CB. Okay, there are many terms that can be cancelled out. So LACA square plus LACACB plus LBCB, sorry, LACACB. It will be 2 LACACB, right? 2 LACACB plus LBCB square, correct? Minus LACACB minus LBCACB. Hmm. LB, LACA, LACA square, LACACB, LBCACB. It is LBCACB, sorry. LBCACB, right? LACACB, LACACB, LBCACB, LBCACB. So this is cancelled out, divided by CA plus CB whole square minus LA LB divided by LA plus LB. Now go on. This is LA CA square plus LBCB square. This is going to be interesting. LA plus LB minus LA LB CA plus CB whole square divided by LA plus LB LA plus LB, sorry, LA plus LB CA plus CB whole square. Now simplify this too. So LA LB CA plus CA square. So there is also the possibility of cancellation. So LA square CA square. So we can say LA CA whole square plus LA LB CA square. LA LB CA square can be cancelled from this, and plus LA LB CB square plus LBCB square minus minus LA LB CA square. This is minus LA LB, sorry, 2 times LA LB CA CB, minus LA LB CB square. So check this out, LA LB CA square. LA LB CA square cancels out. LA LB CB square, this also cancels out. Whole divided by equal to, okay, I have already written equal to LA plus LB CA plus CB whole square, and go on, is equal to, this is LA CA square LB CB square, this is minus 2 LA CA LB CB. So this is the perfect square, LA CA minus LB CB whole square divided by LA plus LB CA plus CB whole square. This is the value of our L2, right? This is the value of L2. So I'm going to edit this style in red, correct? This is going to be the expression. I think you understood this. Okay, let's move forward to equation number. This is the overall equation of equation number 3. Equation number 3 is this, and now we will try for equation number 4. So this is very complicated equation, so we have to solve this very carefully, right? Question 3 is very tricky. Question number 4, let's try to make this happen. Let's copy this equation. Okay, very gently and smoothly we copy this equation here. This is equation 4, correct? This is the equation 4, and we will write this for equation 4. What we see here is that P3, there is also presence of P3, there is P2, there is too much happening here. So we need to carefully solve this equation. There are too much L1, L2, C1, C2, L2, C1, too much is here. So when we try to find out the expression of which expression is remaining, I think C2 is remaining. C1 is already calculated, and then we calculated L1 and L2, and now C2 is remaining. C2, the term C2 is present here. This is C2, this is C2, this is here C2, right? So we already know that. What is P3 then? Do you know P3? P3 is C1, and P2 by P4 is L1. And remember this expression. This expression is which contains P terms and C1 L1 terms is L2. So we have to use these two values, L1 and L2 values. So you understand that the sum of L1 and L2 is P1 C1 minus P4 by C1 square, right? We can write that also. And another one is that C1 is equal to P3. C1 is equal to P3. Very tricky. So P3 is C1. So this part is C1. Okay, P3 is C1. There is only one P3. So there is also P2, right? C1, P1, L2, C2. So where do we start? Is there any cancellations? P1, L2, C2, C1. What is P1 then? We don't know the P1, the value of P1. We know C1. First, we have to collect the values of C2, the coefficients of C2. Find C2 at first and make a fraction of C2. I think that will be the best method. There is no other simplification method that we can remember. Right? P2 C1 plus C2, right? C2 P1 L2 C1 is equal to C2 P3 is C1, so L1 L2 C1 square. So I can write this as C1. As far as practicable, we have to eliminate these parameter terms, P terms, plus P4 L2. This is the C2 expression plus P4 L1 C1 plus P4 L2 C1. P4 P4 L1 C1 P4 L2 C1. Okay. Okay. Now move forward. P2 C1 plus P2 this and C2 this. So the C2 can be calculated. Can you say? C2 can be calculated. How we can calculate the C2? Mm, 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 mm. C1 square this minus this. So we have to subtract this. I think to the right side. Make this to the right side. Make this to the left side. Okay. P4 L1 C1 plus P4 L2 C1 minus P2 C1 divided by divided by mm, divided by this is the negative term, so we can write P1 L2 C1 minus L1 L2 C1 square plus P4 L2 P4 L2. Remember what is P4 L2? Now arrange these terms. P4 C1 L1 plus L2 minus P2 C1. So we take C1 common, P4 P2. Take C1 common here, divided by divided by we can take uh, this term P4 L2 is P2. I have already told you that what is the value of L2. Sorry, L2 is P1 C1 minus P4 by C1 square, and L2 is this, but L1 is P2 by P4, right? So P4 L1 is P2, but here is P4 L2, so it is not possible here. So we take L2 common, P1 C1 minus L1 L2, sorry, P1 C1 minus L1 C1 square plus P4. Right, we can also take expression like expression, it is similar to the expression of this. Remember P1 C1 minus P4 minus L1 C1 square. P1 C1 minus P4 C1 plus P4 minus this. I think I have done some mistake. I don't remember. Mm, oh, it is minus here. It is minus here. So plus minus. It must be minus. P1 C1 minus P4 divided by C1 square. Right? Divided by C1 square. This P1 C1 minus P4 divided by C1 square minus L1. Remember? When you are going to calculate C2 from this expression, so the fraction is made like this. So we have to reduce this fraction as far as possible. So remember that some expressions may become similar to the above expressions. So when I write this, when I write like this, C1, I can write the above expression like before, L1 plus L2 minus P2. The above expression, I will talk about it later. And this expression, L2, P1 C1 minus P4 divided by C1 square, right? L2 by, I will take C1 square common. C1 square common from this. P1 C1 minus P4 by C1 square. These two terms. Remember these two terms. This and this. These two terms. These two terms divided by C1 square and minus L1. Do you remember what is this? Minus L1? Yes, this whole expression is L2. This expression is L2. So say this is equation 5, right? So from equation 5, this is equation 5. See equation 5, right? We can say write the above expression as it is. P4 L2 plus, sorry, L1 plus L2 minus P2. This is equation 5. So C1 square times L2 times L2. C1 square. So C1 cancels out from here. P4 L1 plus L2 minus P2 divided by C1 L2 square. Correct. What is the value of L1 plus L2? Do you remember? Yes, P1 C1 minus P4 by C1 square. It is the same value as we have calculated down there. P1 C1 minus P4 by C1 square. L1 plus L2 value. So this is L2 and this is L1. So we have to add these values. Should we have to add these values? I don't think so. Now move forward. Minus P2. What is the value of P2 and what is the value of P4? What is the value of P2 then? P2 is LA, CA, LB, CB. P4 is CA, CB, LA plus CB. P2 and P4. Do you remember what is the relationship between P2 and P4? Ratio of P2 and P4. Do you remember? Do you remember P2 and P4 is the ratio of L1. So P2 by P4 is L1. This is the equation. What was the equation? It is. I have not written the equation for this. Let's say this is equation 4.1. Okay, equation 4.1. So P2 by P4 is L1. This is equation 4.1, isn't it? P2 by P4. Let's check this out. P2 by P4. P2 by P4 is L1. So write it down like this. Like P2 is L1 P4. Wait a minute. P4 is P2 by P4. P2 by P2 by L1. Sorry, P2 by L1. Yes. So it doesn't matter which expression is larger, P4 or P2. P4 and P2. So P2 is easy to write. P2 is easy to write. So P4, I have to write P4, P2 by L1. P2 by L1. So P2 it's taken common P2 by L1. So first write it properly. P4 is P2 by L1. Hmm, we can write P2 is equal to P4 times L1 also. P4 L1 plus L2 minus P2 is P4 L1 divided by C1 L2 square. Remember, this expression is written like this from equation 4.1. Okay, now move forward. P4 divided by C1 L2 square, and here is P4 is taken common, so L1 plus L2 minus L1. L1 is cancelled out, so we get P4 divided by C1 L2 squared times L2. L2 is cancelled out, we get P4 divided by C1 L2. So what is P4? Now you will get, so this long expression is break down into this form very conveniently. This is P4 and this is C1 L2. So what was the P4? CACB LA plus LB. CACB LA plus LB divided by what was the C1? C1 was, I think, CA plus CB. What was the C1 value? CA plus CB, right? Am I doing right? I think so. This is P4, P4L1, P4L1 and P4L2. P4 is taken common and L1 part is cancelled out. Only L2 is remaining. L2 is L2 square in the denominator. So CA plus CB is C1. Put values. Now put original values here. And what is the value of L2? We have calculated. Do you remember? Yes, this LACA minus LBCB whole square. LACA minus LBCB whole square divided by divided by LALB CACB whole square. LA plus LB, right? LA plus LB CA plus CB whole square. This cancels out with this, and the expression becomes, write it properly so that there is no mistakes. This and CA plus CB LA plus LB whole square divided by LACA minus LBCB whole square. Correct? And hence the value of uh, which value? Value of C2, right? This is completely the value of C2, and C2 is CACB CA plus CB. First multiply and then add LA plus LB. Now inductor square divided by LACA minus LBCB whole square. This is the required expression. Okay, it's now over for this class. I think you understood many things, many expression, many calculations for double tint filter. We calculated C1, C2, C3, C4. We did many things mathematically. Okay, thank you very much.